Hello, this is a tutorial on getting the first two of your four golden equations. So, we're going to start off trying to find the displacement of an object that has constant uniform acceleration. We're going to start off with a couple equations that we already know. First, we have this equation for average velocity. It's the simplest of the equations for average velocity that we'll talk about, and it's a good sort of bedrock equation. Okay, well that's true, what about this? Is it also true that your average velocity for any trip is your initial plus your final divided by 2? Yeah, it's just like taking an average of 2 test grades or anything else. Add them together, divide by the number of things you've added. So we have two equations for average velocity. That means we can set this equal to this. Okay, so far so good. We've set our two equations for average velocity equal to one another, and we've incorporated some things that we didn't have in either of them. Now, this is only true as long as you have constant uniform acceleration. So the acceleration is not changing wildly. That's the only circumstance under which you can use this equation. Okay, now let's rearrange to solve for the displacement. Well, this is a perfectly respectable solution. We typically rearrange it to look like this. And that's the form that you'll probably want to record on your note card. Delta x equals 1/2 vi plus vf delta t. That equation just comes from these two equations for average velocity. When would you use this equation? Any time that one of these four things is what you need to know, and three of them are what you do know. I know, it sounds ridiculously simple, and it actually is. Now, you are assigned all the practice problems on page 53, and they can all be solved using this equation. Why don't you go ahead and try them before you go on to the next equation? Okay, are you done with page 53? Good. So now we're going to look at a different situation. One where we want to find the displacement, but we don't know what our final velocity is. Well, again, we can use some equations that we do have to rearrange and create a hybrid equation. Again, we're starting off with the simplest of equations that we use. Acceleration is equal to the change in velocity over the change in time. We can express that one other way, though. We can express that as acceleration is equal to the final velocity minus the initial velocity divided by delta t. Well, wait a minute. I thought we wanted to do this when we didn't know what delta t was. Or we needed to find, we didn't know what final velocity was, or we wanted to find final velocity. Let's rearrange to solve for final velocity. So we now have a delta t is equal to final velocity minus initial velocity. If we want to solve for final velocity, it's really easy now. So for any object that's got constant acceleration, the final velocity is equal to the initial velocity plus its acceleration and the amount of time that it accelerates. A delta t plus vi equals vf. More commonly written like this. This is the second of the derived equations that you'll want to write on your card to have for future use. Okay, well great. So we've got an equation for final velocity using initial acceleration and time, which we can use anytime that we want to know one of these four things and we know the other three. But I thought you said we were going to find displacement. We are. There's your second golden equation. Let's move on to your third and some more practice problems. Okay, so you have to remember what we just had on the last slide. Okay, v final, velocity final, is equal to v initial plus a delta t. Great. Well, if this is all equal to velocity final, it seems to me we've seen that someplace else before. Don't forget that from your very first golden equation, delta x equals 1/2 vi plus vf delta t. Well, here's the thing. We can take all of this, which is just equal to VF, and we can plug it in right there for VF. Sound monstrous? It's not really. Watch. Okay, so we've got it in the plugged in form where we took everything up here and put it right in there to substitute for VF. Now we're going to do a little bit of simple algebra. Well, VI plus VI gives us 2VI plus A delta t times delta t. And this is all still equal to delta x. Okay, now let's do a little bit more algebraic magic and we'll get our final third equation. If we distribute the delta t, we get this. Delta x equals 1/2 2vi delta t plus a delta t squared. One more algebraic step and we've got our third equation. What do we get when we multiply 2 by 1/2? We get 1. So let's distribute our 1/2 and we get delta x equals 1/2 vi delta t. Delta x equals vi delta t plus 1/2 a delta t squared. That's it. That's your third golden equation. You'll use this one a lot. When will you use it? Well, you're probably figuring this out by now. When one of these four things is what you want to use and you have the other three of them. With that, all the practice problems on page 55 are assigned. I think you've got enough work to keep you busy. I'll see you tomorrow.